Today we're taking a look at section 8-3 on testing a claim about a proportion P. So we have several assumptions we need to go over. First of all, the sample observations are a simple random sample. So we're talking about each sample of size n has an equal chance of being selected. Okay, the conditions for a binomial distribution are satisfied, so we can only have two outcomes, two possible outcomes, fixed number of trials, a constant probability. The conditions NP are greater than and equal to 5 and NQ greater than and equal to 5 are both satisfied. So the binomial distribution of the sample proportions can be approximated by a normal distribution with the mean of the population equal to NP and the standard deviation of the population equal to the square root. This is a square root that goes all the way around that of NPQ. Okay, N denotes the sample size or the number of trials. P hat is the sample proportion X divided by N. P represents the population proportion, and Q is the complement of that, 1 minus P. Now, the test statistic for testing a claim about a proportion, we want to take P hat minus P. And again, you can see I've changed this from a complex fraction into a simple fraction times the square root of n up on top divided by the square root of PQ. Now P is coming from the null hypothesis. P hat, of course, is our sample proportion. So where you get P is from the null hypothesis, and Q then will be the complement of that. So let's look at an example. Adults are randomly selected for a Newsweek poll. They were asked if they favor or oppose using federal tax dollars to fund medical research using stem cells obtained from human embryos. Of those polled, 481 were in favor, 401 were opposed, and 120 were unsure. A politician claimed that people don't really understand the stem cell issue, and their responses to such questions are random responses equivalent to a coin toss. Exclude the 120 subjects who said they were unsure and use a 0.01 significance level to test the claim that the proportion of subjects who respond in favor is equal to 0.5. That was the politician's claim. What does the result suggest about the politician's claim? Okay. All right, so our null hypothesis is the politician's claim. P equals 0.5, and notice I've identified that as the claim. That plays a part in what the type of wording that we will use in our final conclusion. So we want to make sure we understand what the claim is. All right, now next, since the null hypothesis is that it's equal to 0.5, that means that our alternative would be that it's not equal to 0.5. And our P hat comes from the survey. We were told to ignore the 120, so we have 481 plus 401. We have 882 that are participating, and the P hat represents the proportion that favored the stem cell research being funded federally. So we have 481 over 882. We're told we're to test it at the 0.01 significance level, so that's our value of alpha. Our n, our sample size, because we excluded the 120, would be 882. So we move on to calculating our test statistic, and when we have a significance level of 0.01, what happens is we get 0.005 in each of the tails. And that means our critical values are negative 2.575 and positive 2.575. So here are our critical regions. All right. So, calculating our test statistic, you'll notice I go ahead and use the fraction. I just simplify the fraction and then subtract 0.5 from its decimal equivalent. Multiply that answer by the square root of 882, and then divide that answer. Our square root of 0.5 times 0.5 will be 0.5, and I came up with 2.69. So here's where our test statistic is falling. We can see it's inside the critical region, so we will reject the null hypothesis. That means, and again, page 391 is where you can get the wording. So the original claim includes equality, and we reject the null hypothesis. So it's the third one down. So it says there is sufficient evidence to warrant rejection of the claim. So I just said there is sufficient evidence to reject the claim that the proportion of those favoring stem cell research being funded by government actually is equal to 0.5. This suggests that the politician is wrong in his claim. Now, how would we do this particular problem on a calculator? So let's take a look at, let me see if I can get to it here. And this will give us the p-value interpretation of the, and I think I'm going to have to move my window over. Okay, looks like we're getting most of it on here. Alright, so let me clear what I was doing on here the last time. Alright, so we're doing a hypothesis test involving a proportion. So we want to go over to tests, and notice that we have a z-test. This is for a mean. A t-test is for a mean. The one we need is number 5, the one proportion z-test. So we're going to go to number 5. Now, p sub 0 represents the proportion from the null hypothesis. So that was the one the politician came up with. And our number, and I may have to go back and look at these, we had, take a quick look back. My two numbers, 481 out of 882. Okay, so I need 481, enter, out of 882. And our alternative hypothesis, we want to identify it's the proportion is not equal to the figure from the null hypothesis. So calculate is where we want to go, and I'm going to enter on that. Okay, now you'll notice it came up with the value of our test statistic, the 2.69 that we came up with. Okay, it's got p hat. It also has n. This p, and I think this is why I kind of avoided the p-value for so long. The p in this case represents the p-value. Okay, So at least they say proportion is not equal to 0.5. So the p-value, as we look at this, the p-value is less than the significance level of 0.01. Anytime the p-value is less, we reject the null hypothesis. If the p-value were greater than or equal to the significance level, then we would fail to reject. But since our p-value this time is less than the value of the significance level, we would reject the null hypothesis. So the end result in terms of rejecting the null hypothesis is the same. Whether you're using the test statistic and the critical values like I did, or whether you're using the p-value, which is probably the easiest way to do it when you're doing it on the calculator. So that would be the result.